Not yet? All right. It's all good. Yeah, as I said, like if any questions do come up, please just let me know. I'm sure you will probably have some things. There's probably some things I haven't explained very well, but we'll get there together, hopefully. All right, otherwise we're going to pick up from where we left off on Tuesday. So it looks like everyone's brought their laptops, which is good. So yeah, you're all welcome to work through these examples with me. And again, while there will be slides and I'll be standing up here talking, think of this as more a tutorial sort of session. So if something's not working on your computer, you don't understand something, just let me know and I can come over and have a look. This doesn't have to be me just standing up here talking. You guys feel free to play around, and if you don't have to follow what I'm doing on the board either. If you were like, oh, I wonder what would happen if I do this, try it. And if it doesn't do what you'd expect, or if it doesn't work or whatever, feel free just to shout out and I'll come and have a look. We've got plenty of time this intake to look at programming, because that's been a sort of common request of the last few groups, so it's all good if it takes us longer than normal to get through the material. Okay, so we talked on Tuesday about some programming basics. We talked about variables, what a variable is, how to assign variables. We talked about what the difference between primitive and composite variables are. We looked at some examples of primitives, integers, floats, chars, and booleans. We also talked at the end about the difference between an int and a long, a float and a double, where to use each and why. Hopefully everyone still remembers that. It's not actually on any of the material, mainly for the fact because unless you're dealing with numbers larger than 2 billion, you can stick with int. And unless you need quite good precision, you can generally deal with float. If you find either of those being a problem, just use long and double instead. And all this is on the processing reference as well. It talks about when you should use one over the other as well. We talked about how various variables have types, and you can't assign, say, a float to an int, but then we actually said you can convert a float to an int using casting. However, casting is effectively you taking responsibility for the fact that you understand that the machine doesn't know how to do that. So you have to be clear that if you're casting a float to an int, you know exactly what's happening, and so you don't later on say, oh, but it didn't round up. Well, that's not how casting a float to an int works. We talked about comments just because I threw a few of those in the code. So we can do the single line comments with just that, or we can do the multi-line comments with that. And the last thing I wanted to touch on, which we ran out of time on, was arrays. Now, LJ, you have a lecture or something at 12, don't you?
No, it's been 1 o'clock now.
Oh, okay, that's right. Cool. Again, I don't want to keep you guys any longer, especially considering I have 2 lectures today and other work I need to do between them. But it's always good to know if I need to make sure I'm finished by a certain time. So if anyone does have any restrictions which come up, if you have a doctor's appointment or whatever and don't want to miss it, please just let me know. Okay, so we have a piece of our RAM again. We talked about we can assign a variable. So if I say int x, it will assign me some memory called x, and then I can put some data into it. So what an array is it allows us to basically create multiple, it's an array of numbers. So an array is an array because it's an array. So it's basically a whole series of numbers that we can reference. So what that looks like in memory is if I said something like int square brackets. Trying to look at how this is done. Yeah. So int square brackets x will tell the machine that I am going to make an array. The square brackets are used like this to indicate in processing, C, C++, C#, Java, plenty of languages that this is going to be an array. What you'll notice here is we don't actually tell the computer at first, so just looking at this first part before the equals part, we're not actually telling the computer at any point in time how large this array is. So what it will do is it will just hold off on actually allocating any memory until we give it some indication of how long that's supposed to be. So if I type in Still got processing open here somewhere. If I type in int x like that, that'll work just fine. But if I then try and say, set a value of something on x, we'll notice it'll say local variable x may not have been initialized, because it knows that it's an array, but we haven't told it how big the array is, so it doesn't know how much memory to put aside. So there's a few different ways in processing of letting the machine know how big the array is. The first one we have here is kind of a, in fact, I'll probably turn these two things around, but the first one is kind of we tell it the size, but we also tell it the values of the array. So say I want to put 3 values into my array of integers. I can use these squiggly brackets, and I can give it the values separated by commas. And what that will do is it will tell the computer, firstly, that my array is 3 of length 3. So we can see there's 3 items in there, but it'll also tell us what those 3 items are. So if I say int x equals squiggly brackets 1, 2, 3, what that'll do is it'll set aside 3 integer pieces of memory, and it'll set 1 to 1, 1 to 2, 1 to 3. So with arrays, basically everything we do with an array, we do using these square brackets. So what happens if we want to get that first one is we use that x, and if we want to get the first element, again remembering that most sane languages start counting from 0, the first element will actually be x with 0 in square brackets. That is basically the reference to that one there. So we know it's array x. We use these square brackets to say we want to get a value out of the array, and the value in there will be the index of it. So this value here will be represented by x, 0. This one will be x, 1, and this one will be x, 2. So we have 3 pieces of data in our array, and we can access them by using square brackets with their array index number. So just to show you that I'm not lying, that will print 1, yep. So we're getting the 0th item, which is the first, because that's how we do it in computer science. If we say x2, that will be the 3rd item, so 0, 1, 2, and we'll print out the value 3. And likewise, I can change these numbers to anything as long as they're all integers, and this will work just fine. So this one will be 3,431. So we can't go outside of the bounds of the array. So if I say 4, even if I say 3, that's index 0, index 1, index 2, and there is no index 3. So if I try and run this piece of code, it'll tell me there's an array index out of bound exception, which is an exception. B is synonymous with an error, and everything else should be fairly self-explanatory. The array index, so in this case 3, is out of bounds. This array only goes from 0 to 2, and I've asked for array index 3. So if you see an array index out of bound exception, it means that you're trying to access something outside of your array. Likewise, if I try to go the other direction, I'll get the same problem. This is not true of Python, but we're not talking about Python in this class, so let's just ignore that. Okay, so that's the first way or one of the ways of creating an array. But let's say I don't actually know at this point in time what the values are, but I still want to be able to use my array. So at the moment I can't even say like set the value of x0 to 1 because it hasn't been initialized, no memory's been put aside. So if at the time I'm creating my integer array, I know the size of it, but I don't know how many or what the items are going to be inside of it, I can say equals new integer and then put the size of the array in it like that. So new is a keyword that we haven't come across before, but basically new is synonymous in the computer with put aside some memory. I'm going to be doing something later on and I want you to create some new memory for it. So in this case we're saying create some new memory for an integer array. So we're seeing this int with the square brackets again, and this time we see the 3 inside. So we're basically saying x is an array of integers and set that or give that some memory so the new keyword allocates memory, and make it 3 long. And then from there we can start accessing all our memory bits as we see fit. Oops. And that will all compile quite happily. Again, because we've specified how long the array is, if I go out of bounds, so this array only goes up to index 3, which is index 2, well, there's only 3 long, which is only up to 2. If I try and set something into 3, we'll get this array index out of bounds exception again. Right, so the question is, what happens if I do, nothing because printf is from C. What happens if I do this? So I have created my integer array of x's. I have allocated some memory of it of length 3, and now I'm going to print out what's in x0, but at no point in time have I actually set the value of what's in it. Does anyone want to hazard a guess at what it's going to print out?
0.
So in this case, it's going to print out 0, because processing is a generally fairly safe language, and it knows that if I'm creating a numerical value and I'm not assigning it a value, let's just start with 0. This may not be the case in other languages, so try and avoid doing this. Try and avoid printing out stuff in an array if you haven't put anything in the array yet. So processing in Java and C# will be fine. C++, hit and miss as to whether you'll get a number or whether you'll get something completely different. Because what happens, effectively, these languages, part of the motivation behind different languages is how computationally efficient they are, so how fast they run and stuff like that. And if you think about allocating memory, if this is, you know, the way your computer works when it comes to memory is that it will assign and release memory as it sees fit. So if I ask for some memory to put the string hello in, like that, it'll use that piece of memory until my program finishes running, and then I say, my program finishes, it says, okay, I don't need that memory anymore, let's release that. But it's not actually going to set that back to anything. And there's no guarantee that when I say, give me a new array of integers, that it's not going to grab that same piece of memory and start reallocating that. So there may be something in the memory. With processing and everything, they do this extra step that they will, if it's a numerical thing, if it is an allocation, it will not only assign it, but then it will fill it with zeros for you. But some languages like C and C++ aren't guaranteed to do that. And the reason for that is because that's obviously an extra step. We have step 1, set aside memory, step 2, set that memory to 0. So when we're talking about languages like C and C++, which have been designed to try and be as efficient and fast as possible, they may omit step 2 because that is our job as programmers to make sure that the memory has what is in the memory is what we expect to be in the memory what we have in the memory is what we expect to have in the memory before we start using it. And that's why there's been a whole bunch of, in the last, well, forever really, but particularly quite common in the last 5 to 10 years, there's been a whole bunch of like hacking software leaks and stuff, because essentially what programmers are doing is they are using things which are known as buffer overruns. So if I have set aside some memory here for my thing, and then I have a string which is near that with my new username and my password, what they will do is they'll actually do sneaky little things where, so this is my int array x here. So we have x0, x1, and x2. And what these hackers are doing is effectively asking for things beyond the bound of x, but they're doing it in a way where the computers, like, they sort of circumvent what the computer's expecting. So these pieces of data are still sitting in the memory. They're sitting right beside our other data as far as we're concerned. So if I sort of say, just keep reading past the end of the array, it's fine, you can actually start pulling out of different pieces of memory from different programs or other things. And there's some really quite clever things, like this memory doesn't even need to be necessarily from a running program. This could be a program which has run before, and then when the program's exited, it hasn't cleared all the memory out. So this could be my username and password from when I log into my computer that's just been sitting there for ages. And as long as I can figure out roughly where that is and have access to read that memory, I can pull that information out. So after that aside, my point is, don't do stuff like this. If you're allocating some memory, don't necessarily assume that the computer's smart enough. So, and likewise, you know, if I guess probably a more realistic example would be something like, okay, I'm going to allocate an array of memory called x, and then I'm going to say x of 0 equals x of 0 plus 1. I know that processing is good enough that it's going to clear that memory for me so that x of 0 will now be equal to the value of 1. So effectively we're setting it to x0 equals its current value, which will be 0 plus 1, which is 1. But that may not necessarily be the case in other programming languages. So don't ever do this. If you want to do this, this is the one time I'll say don't be a lazy programmer. Normally I'm all for being a lazy programmer, but this is the one time, you know, make sure you set the value to something so you know what it is before you start using it. Yeah, so that's two different ways of creating an array. The first one, we set all the values beforehand, which is sort of kills two birds with one stone in this case really, but it's not always appropriate. So maybe I have a program where I want people to input their age or something, and so I might just say, well, okay, in this case there are 7 people in the class, but I don't know what their ages are, so we're going to ask person 1 what their age is, and x0 equals age, and so on and so forth. So I might not know that until later on, but I want to set that memory aside to start with. So that may not always be possible, but in that case, always make sure you set up the memory before you start using it. Okay, arrays. Everyone's happy? Yep. So and arrays can be anything as well. So I've used integers here, but I could have an array of chars. Oh. Can't spell today, and in that case I could actually do kind of my own version of a string really. And if you actually look at various programming languages, this is exactly, so in C for example, this is exactly what a string is. It's just an array of characters. There's nothing special or magical about it in C. In processing, obviously, it's a little bit different because it's a composite data type. You can ask it for the length and ask it to convert things to lower characters and lowercase and uppercase and stuff. But in languages like C, this is exactly what a string looks like behind the scenes. Cool. All right. So let's move on. So we now know how we can set up some variables. We know various types. We know how to do arrays. But there's a bunch of stuff we can do with these variables. It's obviously pointless just setting them to a bunch of values to start with and then being done with them, because we could just do that ourselves on a piece of paper. So there are a bunch of operators that we can use to manipulate the values which we store in variables. Predominantly these are numerical, because in computers it's always easy to work with numbers than it is with text, because there's, you know, if I add one number to another number, I know what that's going to be. What does adding one letter to another letter actually mean? What does adding a number to a letter mean? All these things. So there are certain rules. So in programming, letters are predominant. Well, at the level you guys are working at, letters are represented by what's known as an ASCII code. So if I say, for example, char A equals A, if I print out A, I will get the letter A. But if I say cast A to an integer first and print that out, I will get the value 97, because internally A is being effectively stored as a number with 97 in it. And that allows you to do some quite interesting things. So I can say char B equals int a plus 1. I might have to put some more brackets around this so I can figure out what I'm doing. Oh, I need to cast that back to a char at the end. This is when programming starts to get quite ugly. There we go. So at no point in time have I actually said B should be the letter B. I've said that B should be convert A into an integer, which will give us the value 97, as we just saw before. Add 1 to it, which will give us the value of 98, and convert that back into a char, and the value of 98 in ASCII just happens to be B. So you can do some kind of weird things like that. And if you're interested in doing things like that, there are various ASCII tables. Some are easier to read than others. That one is definitely not one of them. Oh. Here we go. If I can pull this up big enough. There we go. So if you remember what I said, the value A has the value 97. So these are just in various, this is decimal, so base 10, hexadecimal, which is base 16, and octal, which is base 8. But the value of a lowercase a is a decimal 97. So I took that, added 1 to it to get decimal 98, and that maps to character B. So I could do something kind of weird, like I could say, let me see if I can do this. Char 4 plus char 101 plus char 108 plus char 108 plus char 111. And if this actually works, which I don't guarantee that it will, 532. Okay, so I'm just going to put some things in here, and I'll explain what I'm doing in a second. Hello, there we go. So basically what I've done is I've looked up the values. 104 is H, 101 is E, 108 is L, oops. 108 is L, and 111 is O. So I've basically found the ASCII codes for H, E, L, L, O, and I'm printing them out. Now the reason it didn't work at first is because it was just adding all those numbers together. So I added 104 with 101 with 108 and so on and so forth. And this is a little, so what I did is I added these things in here, which is a little cheat. So if I just add these numbers together, it's effectively like saying 104 plus 101 plus 108 plus 100, whatever it was, 110, etc., which we know is going to evaluate to a number by putting these in here. So this is, we've seen before that 2 quotation marks like this is a string. 2 quotation marks just on their own is a string with nothing in it. So basically what I'm saying when I add in these quotation marks like this is treat everything like a string. Don't try and add these things together because they're not numbers. These are actually characters and should be treated as part of a string. Probably a way to show this which would have made potentially more or would have been slightly less confusing would have been instead to do it this way. And basically rather than having one print statement where I'm printing everything out would be to have multiple print statements where I print each letter at once, remembering that print doesn't put a new line in at the end of it, and that says hello again. So we're basically printing out each letter at a time. But yeah, bit of a digression there. But yeah, effectively characters are numbers, integers, floats, longs, even booleans. So booleans we talked about on Tuesday can have the value true or false. True has the value 1, false has the value 0. Strings are just arrays of characters which resolve back to numbers. So everything you can think of in one way or another as a number in a program, which is why when we look at our programming basics, you'll see that most of our things are mathematical because That's just what computers like to deal with. The fact that this number happens to represent a letter which has some meaning to us humans is kind of irrelevant to the computer. All it's doing is crunching numbers. The fact that the result of it at the end is something that we as humans can understand, the computer does not really care about. Okay, so let's do some operations. Oops. So I'm going to create two values, x and y, and I'm going to print out x plus y, which hopefully everyone will be able to tell me the answer is 3, because 1 plus 2 is 3. So that's pretty straightforward. Likewise, we have the subtraction, which will be 1 minus 2, it's -1. This slash here is divide, sorry. So you can think of that as x over y is a fraction, which we can basically calculate by dividing the two of them. So x divided by y, in this case 1 divided by 2, will give us the value 0. You might say, why is 1 divided by 2 0? It should be 0.5, and that's because they're both integers. So if we're dealing with integers and we do a division, the computer isn't smart enough to say, oh, this integer divided by this integer is actually floating point, let's convert it to floating points. That is our job. So if we want to divide two numbers, which we know, and we want to make sure that it gives us a floating point result, turn them into floats first. So float x of 1, float y of 2, x divided by y will be 0.5. Whereas if it's just integer and integer, it'll just remove everything after the decimal place and give us the value 0. So the star is multiply, so 1 times 2 is 2. Pretty straightforward. And the last one I wanted to talk about, I'm not sure why there's an exclamation mark there. Actually, I think I know. I've never used it before, but is this percentage sign function, which you might think has something to do with percentages, and it doesn't. So in programming, when we're talking about this symbol here used in mathematical, it's actually known as modulo, and basically what it means is what is the remainder of dividing these two numbers. So if I have, let's pick two nice numbers, 3 and 2. So 3 divided by 2 is 1.5. If I just say 3 divided by 2, using integers, I'll get the value 1 because it's truncating it down, it's converting to an int. But I also know 3 divided by 2 is 1 with a remainder of 1. So if I go 3 divided by 2, I will get 1 as the value. Likewise, if I say 5 and 3, so 5 and 3, 3 goes into 5 once, so it's 1 point something, and whoops. But if we say, actually, I'll just put those in there. If I say 5 modulo 3, that will be going at 1 time with 2 left over. So 5 divided by 3 is 1 with a remainder of 2. And that gives us a remainder of 2. The reason modulo is quite important is oftentimes we will, and we'll talk about this when we get down to these control statements, we want to do something on every something piece of data. So if we wanted to do, say, every third piece of data we want to multiply by 5, it's pretty easy for us to find if it's the third piece of data because you just divide it or do the modulo of 3, and if it comes back with a value of 2 or whatever one you want to set it as. So maybe I'll draw this up on the board because it might be easier to explain visually than. So let's say I have these array values. So 1, 2, 3, 4, 5. And let's say this is my array x. So this will be x0, x1, x2, x3, x4. And let's say, in this case actually, let's say every second number I want to multiply by 5 for some reason. So what I can do is I can basically go through every one of these And I can say, if we just say this number here will represent that as IDX for index. If IDX modulo 2 is equal to 1, and we'll talk about what this equal symbol means first. So if IDX modulo 2 is 1, then it is a second number. So in this case, 0 modulo 2 will give us a value of 0. 1 modulo, sorry, other way around. 2 modulo 0, so 2 divided by 0 is 0. 2 divided by 1 is, no, sorry, I was right the first time. 1 divided by 2 is 0 with a remainder of 1, so a remainder of 1. 2 divided by 2 is 1 with a remainder of 0. So I'm going to write these out as I go because otherwise I'm confuse myself. So what do I say? 0 divided by 2 equals 0 remainder 0. 1 divided by 2 equals 0 remainder 1. 2 divided by 2 equals 1 remainder 0. 3 divided by 2 equals 1 remainder 1. 4 divided by 2 equals 2 remainder 0, and so on and so forth. And so by doing this modulo operation, effectively what we're looking at is what's the remainder. And you'll notice that for every second number in this array, it is 1, it is 1, that would have been 1, that would have been 1, and so on and so forth. So we can really easily do things on every something piece of data or every something operation simply by doing the modulo of that number. And using these loops down here that we'll talk about soon, this is something you'll do very, very commonly. So you want to do something to you want to get every third number out. Or say you're passing some text file where you have like values stored in, it's what's known as comma separated values. So if you get an Excel file, actually let's see if I can open Excel and show you. Sorry, this is super slow opening on my laptop. But basically, say we have a big thing of data. I don't care what's new in Excel. Nothing I'm ever likely to use. Okay, so say this is my Excel file, and in this I'm going to put first name, last name, age. So Bob Kelso, 53. Try and remember some of the characters' names from Scrubs. And so on and so forth. So imagine this is some data file. Sorry, that's quite hard for you guys to read. And oh, there we go. But we have first name, last name, age. What I can actually do, because Excel files are super hard to actually read normally, is I can choose to save that as, and go down to CSV, comma separated value, encoded in UTF-8. But if I save that out, and that should be somewhere there. If I open this in, what can I open it in? Processing, read it. Is that going to throw a little fit? Nope, that's not going to. What do I have on here? So ignore this stuff on the side, and you probably can't read the stuff on the possibly can read the stuff on the left. So this is what the text file looks like. So you see first name, comma, last name, comma, age, and then there's a new line character in there. This program doesn't print new line characters. Bob, comma, Kelso, comma, 53, new line, John, comma, Dorian, comma, 30, new line, Chris, comma, Turk, comma, 32. So if we were looping through all of these and we just wanted to say find the person's age, we could loop over each of these things, and only if the index is modulo 3, because they come in groups of 3, is 2, will it be the third one. So we could very quickly pass through this without having to try and figure out, oh, is this the person's first name, is it the last name, is it the age? We just say, well, we know the age is always the third one, so if the index is modulo 3 is 2, it's the third value, and that will be the person's age. again, we will come back to that soon, and I'll show you a working example, and hopefully that might make more sense. I'm just going to leave that bang operator off there for now because I can't remember what it does, but I'll test it in the break and have a look. This is something which I think is processing specific, and I've never used it outside of processing, and I've never used it outside of class, so every time this rolls around, I remember that I probably should have checked my notes before I came into the lecture, but I'll check in the break and I will come back to that, because I do know what the rest of these things do. Okay. So these mathematical things are all basically allow us to change the value of a variable by adding something or dividing something or so on and so forth. The next set down are comparison operators, and they basically allow us to compare the values of two variables or two pieces of data. So if I have int x equals 3 and int y equals 5, I can print out x. Now when we think about equals, we usually think of it as an assignment. So we might say, if we're talking about math or whatever, we might say x equals 10. And we understand that to mean, x is 10. We might also say x is equal to y, which means we say they're the same value. But if you tell a computer x equals y, that means that the way it interprets that is x should have the same value of y. It's not a does it have the same value, it is a make it have the same value. So instead, this is what's known as an assignment operator. So we're basically telling it make x equal 3, make y equals 5, make x equal the value of y. If we want to compare them, we do 2 equals. And that is a comparison operator, and it's asking, instead of make it x, it's saying is it the same, or sorry, make it y, it's saying is it the same as y. So if I print this out, we'll see the value is false, because the value of x is 3, the value of y is 5. So does 3 equal 5? No, it doesn't. That statement is false. If I set x to 5 and y to 5, then it will tell me true. X and y both have the same value. Now you notice that said true and false. That is because the result of comparison operators is a Boolean, like we talked about before. A Boolean can have the value true or false. So I could say, are x and y the same equals x equals y. So that will basically calculate this thing, is x the same as y, true or false, and store that value in x and y the same. So true if they are the same, and false if they're not the same. Okay, so the one next to it with this, so when we see an exclamation mark in programming, it's called bang. Some people call it an exclamation mark, but they're not right. It's called a bang. I don't know. It's supposedly called a bang. No one ever actually calls it a bang. The number of people I've said, bang equals, and they're like, what are you talking about? So if somebody says bang, you know that they're talking about an exclamation mark. But most of the time I'll probably say, in this case, not equal to, because that's what that means. So if equals equals means are they the same, bang equals or exclamation equals means are they different. So are x and y different is x, and sometimes actually this will be, people describe this as not. So x not equals y. So in this case, if x is 3 and y is 5, they are not the same. So x not equals y will be true. If they are the same, so x is 5, y is 5, then x not equals y will be false. So we have one thing for calculating whether something is true, and one thing for calculating whether something is not true. Then we have the usual mathematical operators. So less than, greater than, less than or equal to, or greater than or equal to. So is x less than y? So is x less than y in this case? Yes. Yeah. Is x less than y? So x is 3, y is 5, 3 is less than 5. So that is true. However, is x less than 5 now? Is x less than y now? So I'm getting some yeses, getting some nos. It is not. So 5 is not less than 5. 5 is equal to 5. So that's less than, and I don't know, there's numerous ways of remembering this. The hungry crocodile always eats the bigger number, or you know, it points to the smaller number. It's just what it is. You get used to it. So in this case, it's pointing the other way. So the hungry crocodile is eating the larger number. So we're asking now, is x greater than y? So if x is 7 and y is 5, is x greater than y is true, because 7 is greater than 5. And likewise, as we saw before, 5 is not greater than 5. 5 is equal to 5. So if we wanted to catch those last two statements, we have these things where we have, oops, sorry, wrong way around. So is x less than or equal to y? So less than or equal to. So x is 2, y is 5, x is less than, yes it is. But now if x is 5, so it is the same, it is also true. So this is only false when x is larger than y. And likewise, we have the other one, is x greater than or equal to y. In this case, it'll be true because x is 6, y is 5. If x is 5 and y is 5, that's also true. But if x is 3 and y is larger than it, then it is false. So all of those are straight out of math. Like, hopefully it's nothing too surprising or confusing there. These last two, though, are probably new to you guys. Oop, and I've just dragged them into the wrong place in the document. And they're specifically for dealing with Booleans. Actually, that's going to be unnecessarily confusing. Okay, so this first one with the two ampersands is and. So is x true and is y true? So in this case, x is true, but y is not true. So this will give us the value false. If x is true and y is true, that will be true. But any other combination, if say x is false and y is false, will be false. So we have in computer science for these more tricky Boolean tables, we have truth tables. So if this is x up here and this is y here, if x is true, if x is false, if y is true and y is false, and we are looking at the and thing. So if x is true and, if x is true and y is true, and will be true. If x is false and y is true, and will be false. If y is false and x is true, false. And if x is false and y is false, false. So that is basically a truth table for the and operator. So it will only ever be true if both things on either side of it are true. Then we have this one here with two what are commonly called pipes. And that one is the or operator. So the or operator will be true when either of them is true. So if x is true, the or operator will be true if at least one of them is true. So if x is true and y is true, it's true. If x is true, y is false. If x is false and y is true, it's true. If both of them are true, it's true. And if both of them are false, it is false. So if this is the truth table for and, the truth table for or, looks like this. So true and true is true and false. True and false? False and false. There we go. So you can see the difference between the two of them. This one only has true when they're both true. This one is only false when they're both false. So in some ways they're kind of like mirror images of each other. Yeah. And again, these and or things become useful later on when you want to compare things which are more than just dependent on one variable. So we could have, is the weather outside nice and is it windy? I'm going windsurfing. Or is it a Saturday or am I not in the mood to teach? If so, then I'm going to be not going to be in class. And you can string multiples of these together. So you could have this and that, or this and that, or quite complicated statements by stringing all these things together.
Can you put more than two values in?
Yep. So give me an example. Or give me a real world example, and we'll see if we can write the statement for it. So like I said before, with the if it's sunny and it's windy, I'm going windsurfing. Sorry, I know, just throwing you for a loop here. I'm just trying to wake you guys up a little bit and get you thinking.
If it's not raining and if the sun is out and if yeah, if you have money, you'll go out.
Okay. So let's do this as another statement. So go out. So it was if it's not raining and the sun is out and we have money. So three ands. Yep. So not raining and sun out. Now the way this works is we have to think a little bit about the order that we put these things in, because we can't just say this and that and the other. We have to do them two at a time, because the AND operator only operates on two things at a time. So what I can say is that. So if it's not raining and the sun is out, and then if the result of that and the fact that I have money, then we'll get the value of go. Oh. So in this case, if not raining is true, sun out is true, and have money is true, it's true. But in this case, if any of these three things are false, it will be false. So with three AND statements like this, all three of these things have to be true in order for it to happen. And if you think about it, the reason for that is we effectively do this in parts. So you guys hopefully are familiar with putting things in brackets from math. You know, whatever is in the brackets you do first. So in this case, we look at not raining and sun out. So from our truth table here, we know that the only way that this can be true is if this is true and this is true. So if either one of these two is, or if both of these are true, this is true. Otherwise, this is false. So let's look at the case of this is true. Then we basically say, okay, true and have money. So if have money is false, so if we have true and false, it doesn't work. But if have money is true, then we have true and true. I'm trying to think of a better way to illustrate this, which isn't so confusing. So let's say rain and, or not rain, and sun and money. So effectively we look at this separately. So if not rain is true and sun is true, then this whole statement is true. And then we're saying is true and money true. So in this case, if money is true, if money is true, then we have true and true, which gives us an end result of true. Does that make sense?
So why can't you just put them all in one series of
Yeah, I was just going to ask, what happens if you use the bracket at the end of the sentence, which is after money?
So you're talking about putting the bracket all the way out here. Let's see. In this case, I will say that it will probably work fine. Yep. But the order of operations is still going left to right. In the same way, you can say 1 plus 2 plus 3 will be 6. And 1 plus 2 plus 3 will be 6. Or 1 plus 2 plus 3 is 6. We're basically, when we do brackets with these comparison operators, it works in exactly the same way. In this case, and actually in this case because they're all and, that's actually fine. But the question then becomes, what if my equation is 1 plus 2 times 3? That's very different because 1 plus 2 times 3 works out as 3 times 3, which is 9. 1 plus 2 times 3, that's 6 plus 1 is 7. What are the things we can do here? It's probably going to be 7 as well because multiplication always takes precedence over addition. So in the case of and, it doesn't actually matter too much whether you have the brackets or not. As in the case of plus, it doesn't matter if you have the brackets or not. But if we start peppering some ors in there, it's going to get a little bit different. So if I wanted to say something like that. So if it's not raining and it's sunny, or I have money, I'm going out. In this case, it'll probably be fine because there is no order of precedence of and or, so it's going to work left to right. But if I did, so in this case, basically what the statement is saying is if it's nicer weather or I have money, I'm going to go out. But if I move this around, whoops, this way because it works left to right, what this is saying is if it's sunny and either I have money or it's not raining, I'm going out, which is two different statements. In this first one, if I have money, I'm going out regardless. If I don't have money, I'm only going out if the weather's nice. In this one here, I'm only going out if the sun is out, regardless of whether I have money or not. So yes, in the case of when everything's and, it's fine, just as in the case of everything plus is fine. But if I start putting some ors in, then it's like adding a multiplication to it. Depending on the order of operations will depend on the meaning of my thing. So sometimes, what I could do is if this is the behavior that I want, that if I have money, I'm going out regardless. But for whatever reason, I have to write it this way. I can put that in brackets, and that becomes the same thing. Now it checks this one first. So it checks to see if it's nice weather, and then I'm saying if I have money or it's nice weather, go out. Otherwise, what I've effectively written is this one. I'm only going out because of the and if the sun is out. And I'll also go out if the sun is out and it's not raining, or if the sun is out and I have money. So yeah. Putting brackets in is not always a bad idea. So even in the case of the one up the top, 1 plus 2 plus 3 doesn't need brackets, but I personally find it easier to figure out if I do have brackets, because that way I know at least where to start adding stuff together. So yeah, you can string as many of these together as you want. Throwing brackets in is always a good idea because it's just going to make it easier. When you're reading it, you read from the innermost brackets outwards, and that will just tell you, okay, I need to check, is this part true or is this part false? Is that part true or is that part false? And build your way out from there. All right, let's have after that interesting little experiment. Let's have a quick break and come back at about 5 past maybe. Everyone's super excited and doesn't want to miss a minute of it. All right. Okay, so that is comparison operations. So the last thing to look at is assignment, which in some ways should have been the first thing. Oh, so that's right. I said I was going to mention the mathematical operator. So if we have a Boolean, this operation at the top here with the exclamation mark was what I thought it was. It just probably shouldn't be in the mathematical, probably would have made more sense in comparison, to be honest. But basically, an exclamation mark like that just means not. So if I say, which is for a Boolean is the opposite. So if I say y is not x like this, if x is true, then y will be not true, which we know is false. Likewise, if x is false, then y will be not false, which is true. Just as easy as that. Which then hopefully makes a bit more sense as to why if this is equals, this is not equals. Okay, cool. So let's just go through the last through of the assignment and then we'll move on to control statements, which is where programming actually starts getting useful. Okay, so we have some assignment statements. So we've seen some already. Int x equals 5. This equals here is an assignment statement. We're saying make x be the value of 5. Likewise, if we say x equals y, we're saying make x be the value of y. So in this case, x will be 10. Okay, so there's a few other ones which are more or less useful depending on what you're doing. So we have plus equals, which is basically the same as writing x equals x plus y. So take the value which is currently in, this is basically saying take the value which is currently in x and add to it the value of y. So if the value of x currently is 5 and the value of y is 10, x plus equals y will be 15. So we've already got 5 and we're adding 10 to it. Likewise, minus equals is take the value which is currently in x and subtract from it the value of y, which is negative 5. As we saw before, the star is times, so take the value of x and multiply it by the value of y, which will be 50. And the last one, which I might actually swap these values around, take the value of x and divide by the value of y. So if x is 10, y is 5, then x will be 2. Too easy. So they are, again, you know, there's a million different ways to skin a cat when you come to programming. There's no reason for any of these other assignment things to exist. There's no reason why we couldn't just go x equals x divided by y. And some people will choose to do that because it's easier to read. But for me, I guess in this course, the way I see it is I want to sort of show you guys what people commonly do so that when you, because after, you know, we're not going to learn everything there is to know about programming. So there's going to be a fair amount of sort of you guys going out and learning on your own and trying to understand things. And I would like for you guys, if you saw this in the wild, to know what that means. You can look at that and say, okay, they're dividing the value of x by y and storing that in x. Again, so you're not just like, okay, I have no idea what's just happened in here. So that's why I throw them in there, because they are available and people will use them. One thing you'll probably more commonly see is these two, x plus plus. Does anyone know what x plus plus does? So it adds the value of 1 to x. So if x is 10, x plus plus will be 11. So you hear, so basically the plus plus is the increment operator. So it just adds the value of 1 to it, which is, you know, explains why we had C was the original language and then we had C++, because it's one version up from C. Wasn't that clever? Likewise, we have minus minus, which is the decrement and just subtracts 1 from the value of x or whatever. So the reason I mention those two is, as we'll see in a minute with loops, these tend to be very commonly used because in a loop we often want to go through every number one at a time And we can do that by changing the index one at a time and then looking at that number. Okay. Is everyone happy with the operators? Yeah, kind of. You look a bit blank, but it is the sort of thing, play around with them. Try and, after class, if you haven't already installed process, and go back and try and use all of the operators and make sure you understand what they do, how they work. We will be, how are we going for the, we might be able to, I think we'll be able to get through to a point where you'll have some homework over the weekend to do, which will be to go and download some processing code and try and understand how it works and tweak one thing about it. Might just be changing the color of something or whatever. But yeah, the operators themselves, other than a few, like that one, and like those two, and like all of those, are generally, fairly common. There's the sort of things you would have seen in maths and school and stuff. So now we're going to move on to control statements, which is where programming actually starts becoming useful. So we had our example before, is wet, is sunny, have money. And we were able to combine these together with and or statements to print true or false, to basically indicate whether we were going to go out today or not. But true or false doesn't really necessarily tell me a lot if I don't know what I'm saying is true or false. So what we can do is we can use control statements like if, else, and else if to change the flow of our program. So say I want to print out a message if it is wet. I can say if is wet, and I'll write this whole thing out actually, and then we'll dissect the pieces of it. Println, it is wet today. So what this piece of code is doing is basically, if is wet is true, it's going to print out what's inside these squiggly brackets. In this case, it is wet today. So if I run this, is wet is true, it prints out it is wet today. If I change the value to false and spell it correctly, it will print out nothing. So what are the parts of this, I guess? So we know the println statement, hopefully fairly well now. We understand what that does. The if statement basically has sort of three parts. So there's the word if, which tells the computer we're going to do some sort of comparison, and we're going to change the flow of the program depending on that. Then after if, we have these circular brackets. So if, circular brackets. And whatever is in the circular brackets is the condition that we're testing. So in this case, we've got is wet, and we basically just want to see, is this true or is this false? Then the last part is we have these squiggly brackets. And the squiggly brackets is what happens if the part in the circular brackets is true. So in this case, we have in our circular brackets is wet. So if the value of is wet is true, we're going to do everything which is in these squiggly brackets. Otherwise, we're not. And at the moment, we've only got one statement in there, but we could have as many statements as we want. And all of these pieces of code would only get run if the value which is in these circular brackets up the top is true. Okay, so what if we wanted to do something, we wanted to print something if is wet wasn't true? Well, we could use that we saw before. We have the bang operator. So we could say if bang is wet or if not is wet. In this case, if is wet is false, it will execute it. But there's a better way of doing that and a more easy to read way of doing that. And that's by using the else statement. So the else statement attaches to if, and we end up with if, circular brackets, squiggly brackets, else, squiggly brackets. So the first part works in the same way. Everything which is in the circular brackets gets tested, and if it's true, we execute what's in the squiggly brackets. What the else means is if what's in the circular brackets is false, execute what's in the second set of squiggly brackets. So if we look at it like this, it is not wet today. Our if statement says, if it's wet, then execute what's in the first set of squiggly brackets, which is print it is wet today. The else statement says if this is false, do what's in the second set of brackets. So in this case, print it is not wet today. So if I run this, if wet is false, so if is wet, well that's false, so go down to our else statement, print it is not wet today. Or vice versa, if is wet is true, then it is going to say if is wet is true, which is true, then execute what is in the first set of squiggly brackets. It is wet today. Is everyone happy with that? Yep, hopefully. Okay, so there's one more thing that we can do. So let's actually open up another instance of processing. Okay, so we have this example now where I've swapped out having my Boolean statements with some integers. So I have x, which has the value of 5, and y, which has the value of 10. And my if statement now says if x is equal to y, and if so, we're going to print out x is equal to y, and then my else statement says x is not equal to y. So in this case, it will print out, that's right, x is not equal to y because they're different. If I make them the same, then it will print out x is equal to y. So what if I wanted to make this a little bit more, intelligent, provide us with a little bit more information? What if I wanted to know if x is less than, equal to, or greater than y? So what I could do is I could put if x is less than y, then x is less than y. However, if I just have if and else, then all I have is I know if x is less than y or if it's not less than y. I can't tell if it's equal to or if it is greater than. So this will work, x is less than y or x is not less than y. But if I wanted to then say, well, is x less than, equal to, or greater than, I need to have another if statement. So I could do that down here. I could have another if x is greater than y, then do all that. But there's actually another statement called else if, which allows me to chain a whole bunch of if statements together, and it will keep going down that list until it finds something which is true. So if the way that works is we have if x is less than y, then it's going to execute the first one. Otherwise, it's going to go to our second one, and it will say else if x is equal to y. And in this case, it will execute what's in the second one. X is equal to y. And we could have a third one if x is greater than y. And we could have as many ifs and else ifs as we want going down the whole way. So now we have an if statement, and the way to read if statements is just top to bottom and stop when you hit something which is true. So if x is less than y, we're going to do this. Otherwise, if x is equal to y, we're going to do this. Otherwise, if x is greater than y, we're going to do this. So if we set x to 5, it will check the first one, say that's true, so it'll print x is less than y. If we do the second one, so x and y are equal, then it will say is x less than y? No, it's not. Check the next one. Else if x is equal to y, it is, print that one out. And the last one is if x is greater than y, we say if x is less than y, it's not. If x is equal to y, it's not. Otherwise, if x is greater than y, it is. So print out that. So because of the way numbers work, a number can either be less than, equal to, or greater than. Those are the only three options. So this last one could actually just be else, and that would give us exactly the same result. There's no reason why we can't put in that else if, but we don't actually need to write it in that case. All right. Okay, so there's one last thing that I just wanted to touch on with if, else, and everything else. And that is that, as I mentioned, it goes from top to bottom, and as soon as it hits something which is true, it will stop. So if I make this if x is less than or equal to y, so I'll run this now, x is less than or equal to y, when x is 5 and y is 10, less than or equal to y is true, so it will print less than or equal to y. But what happens if x and y are equal? So that's going to be true for both x is less than or equal to y and for x is equal to y. So does anyone want to hazard a guess at what's going to be printed out on the screen? So now this is going to be true and this is going to be true. Yep. Is anything else going to be printed? No? So just the first one. Because as I said, as soon as it sees one which is true, it will do that and then it will stop. It doesn't care if way down here there's something else which is also true, because it has seen this first one and decided that's as far as it needs to go. So that's something you need to just put a little bit of thought into, I guess, when you're writing if statements, particularly if you have sort of catch-alls. Like if we had something, if x is less than 5, else if x is less than 10, else if x is less than 20. So that is going to work very differently than having these other, or that will work completely differently from if x is less than 20, else if x is less than 10, else if x is less than 5. So these two statements, even though they look quite similar, will actually produce very different results. So in the instance that x is between 10 and 20, in this case, let's put some numbers in here. Actually, we'll make these A, B, C. So in the case here that x is 10, in our first one we're going to say is x less than 20? Yes it is, we're going to print out 1. Here we're going to say is x less than 5? No it's not. Is x less than 10? No it's not. Is x less than 20? Yes it is, so print C. So the first one we're going to have 1C. Then if we make this between 5 and 10, this one is still going to be true, so it's still going to print out 1. But this time, this one's going to print out B because it's between 10 and 20. And if we make it less than 5 now, we're going to end up with 1A. So because it's still less than 20, it's going to execute that first piece, whereas this one is going to execute the first piece. So the order which you do your if, else if statements can be quite important. These two things, despite the fact they look like they're testing the same thing, is x less than 20 is x less than 10 is x less than 5. The order that you put those if statements in will matter because it will just hit the first one, which is true, and it will stop. So here we will always get 1. Here we will get B, C, and A, depending on whether it's less than 10, less than 5, whatever. Does that make sense? So it's just one of those things to be a little bit wary of and a little bit careful of. If you're doing like an if, else if chain of statements, just think about, when do these statements overlap, I guess. Or will they overlap, and if so, when do they overlap? Because that will depend on the order you need to write your statements in order for them to do stuff. If we wanted to print out the case that if x is less than 20, print this, if x is less than 10, print this, and if x is less than 5, print this, all we need to do is just get rid of these ifs and just have these else's, and have multiple if statements like that. So now this will print out 1 if it's less than 20, 2 if it's less than 10, and 3 if it's less than 5. Okay, everyone happy with that? Kind of, more or less, hopefully. Have a play with it. There's only so much you're going to learn from me sitting up here talking about it. It's going to be way more useful for you guys to actually practice these things yourself. Okay, so now we're getting on to the useful part, but also probably the trickiest part to wrap your head around. And that is loops. Okay, so we're going to start with a for loop. So a for loop has three parts. Just trying to think how the best way to cover this is. Maybe let's do an example first. Okay, so I have this statement with 3 lines in it, and we can see it has a for in it, and it has a println in it, and it's going to do something when I run it. And when I hit run, we'll see that it prints the numbers 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so this is a for loop which prints out the numbers from 0 to 9. So a for loop has 3 parts to it. Wow. Yeah, 4 parts, I guess. 5 parts, arguably. It has a number of parts to it. So the first thing is the for statement. So the for statement tells us that it's a for loop. The second part is, what that we'll cover at the moment, is this squiggly bracket part here, which works in the same way as an if statement. So everything which is in the squiggly brackets will happen as long as the loop is running. And then the last part, or the last 3 parts, is this part inside the brackets here. So if you think about our if statement, we had ifs, circle, squiggly brackets. Our for looks kind of similar, except this part in the middle actually is made up of 3 separate parts, just to be confusing. So those 3 separate parts we can see down here in this loop. So let's go left to right. So our first part here, which is everything before the first semicolon, so these are actually 3 separate statements we can see by the semicolons. This first part is the initializations. This is what happens at the very start of our loop. So in this case, at the very start of our loop, we're setting some integer called I to be 0. So I is going to start at the value of 0. Our second part is the condition of the loop. And the loop is going to keep running, so it's going to keep executing what's inside the squiggly brackets as long as this condition is true. So in this case, we're going to keep doing what's in the loop, in this case printing out the value of I, as long as the value of I is less than 10. So as soon as the value of I is 10 or greater, we're going to stop. And this last bit here is the increment. And so that's what happens every time the loop goes round, something's going to change. In this case, we're going to add 1 to the value of I. So what we can read this whole thing is we have a for loop here that when it starts, it's going to set the value of I to 0. Every time it goes round, it's going to increase the value of I by 1. So it's going to go 0, 1, 2, 3, 4. And it's going to stop as soon as the value of I is no longer less than 10. So what happens? We start at 0, and then we execute our first piece of loop the first time, println I. So the value of I is 0, we print it, and we get 0. And then we finish the loop, we come back around. Now this is our second time around the loop, so let's increase the value of I because this is our increment. So I plus plus, I is now 1. We check to see if I is less than 10, or 1 is less than 10. So we go through the loop again. We print out the value of I, which is 1, and that's at the end of it. So we come back here, we add 1 to the value of I, we check to see is that less than 10. It's now 2, so 2 is less than 10, and so on. And we go all the way up till we get to printing the value 9. We come back around here, we increase the value by 1, it's now 10. We say, is I, which is now 10, less than 10? It's not, so we exit out of our loop and keep going. Does that?
What happens when you interchange I less than 10 and I increasing the value by 1? What happens when you interchange that?
So you'll probably find it doesn't work because the second one has to be a comparison.
Okay.
Yeah, so integer does not match with Boolean. So this second thing has to return a Boolean because that tells us when we know we need to stop. And if like adding 1 to the value of I doesn't return true or false, it just happens. So that could be any Boolean, but it needs to be a Boolean that we can test in each one. But you have raised an interesting point. So is everyone sort of vaguely comfortable with how this for loop works? Kind of, maybe. Again, have a play with it. The only way you're going to understand it is if you have a play with them yourself. But effectively, for loops have three parts: the initialization, the increment, which happens every loop, and the condition that we test every loop to see whether we should keep going. However, there is no need for those three things to be in there. So what if I wanted to say, okay, I don't like how for loops are written, I'm going to rewrite a for loop. So the first thing I want to do is I know that I needs to start at 0. So I need to have that somewhere in my code. I is going to start at 0. Well, I've got it there. I actually don't want it there anymore. And if I run that, that will actually work in exactly the same way. So I've moved that first initialization statement out of the loop, and it's going to work quite happily. Likewise, it's a little bit confusing to me when this increment happens. Does it happen before the println, after the println? It's a fair enough comment. I get confused by that sometimes. So let's make that explicit. We're going to add 1 to the value of I after we've done the print statement. And if we run that, it works just fine. So the only thing we've got left in there now is our condition. This is going to keep going as long as the value of I is less than 10. And this may be a little bit, this is usually not how people write it, but I find sometimes breaking it up like this sometimes makes it a little bit easier to sort of understand. Because here we can see when everything happens, every time we come to this for statement, we're going to check, is I less than 10? And every time we hit this point, we're going to add 1 to the value of I, and we only set the value of I once before we start the loop. So this is, possibly a little bit messier, but I feel maybe illustrates where the various things are happening a little bit clearer. This happens before the loop, this happens during the loop, and this happens every time we go through the loop. Likewise, we could also move this one out. We could have here, if I is, well, we don't want to know that it's less than 10 now. We want to know if it's greater than or equal to 10, so it's no longer less than 10. There is a keyword break, which will exit us out of a for loop. And so if I run this, we have exactly the same result again. So those two loops there, one with all the bits and pieces broken out, and one with all the bits and pieces included. I'm just going to change that from I to X because it's going to complain that I have 2 I's in my program. Those two loops, other than the fact one has I and one has X, are exactly the same. So there's multiple ways of writing it. The only thing you need to be careful of is you still need to have these 2 semicolons in your for statement. There's just nothing in between the semicolons, so they're just going to tick away quite happily. And all the logic is happening in the loop. So as it turns out, there is another type of loop we can use, which is possibly slightly easier to understand because it doesn't have the weird syntax and layout of the for loop, and that is called the while loop. And the while loop just has, again, looks the same as our if statements and our for statements. So we have I think that's the way around it works anyway. We have circular brackets and squiggly brackets. The squiggly brackets are what gets done, and the circular brackets tells us when to finish. So while X is less than 10, print out the value of X, and if I run this, we'll get the same result as we did from our for loop again. So the while statement only has one argument, and that is just when to stop. And while that is true, it will keep going over and over and over this piece of, this loop of code, and it won't stop until it's done. But the only thing to notice is that, particularly if I stick this back in here, so I make this for loop look like it did before. So now in this one, we've broken out the initialization and we've broken out the increment, and we've just left that one there. That for loop is actually the exact same as that while loop there. So while loops and for loops are interchangeable. The reason you'd use a for loop over a while loop is just because it's slightly tidier. Well, depending on who you talk to. This might be slightly easier to understand as a new person to programming because you can see where all the bits are. X gets set up here, X gets incremented down here, and it gets tested in here. Whereas here it's sort of all smashed into one statement. But for loops are quite common once you get familiar with it because I can look at this for loop and just by reading that top loop I can tell you what the condition is at the start, what the condition is at the end, and what's going to happen every time around the loop. So yeah, feel free to use either. I don't really have strong feelings either way. You will find a lot of people use for loops simply because they're just shorter to write, and again, programmers are lazy. But if you find for loops really hard to understand, do feel free to use while loops. Your code will run exactly the same speed. In fact, your code will probably get compiled down from the code you write to something which the computer understands in exactly the same way. Like if you run this through the compiler, this will end up looking just like this at the end of it. The computer has no idea what you've done. This is just semantics for humans reading it so they can read it and understand it or not. Right, is everyone okay with that? Any questions, concerns, queries? No? Okay. So let's, now that we've just had a quick look at that, let's actually do a useful example. So let's do an array of strings called names. Oops. Okay, so, sorry, this is hard to fit all on one screen. So we looked at arrays before. I said you can have arrays of any data type. So here we've got an array of names. So they are, yeah, it's an array of strings of names, and I've just thrown some names in there. Now, if I wanted to print out everyone in the list, I could go through and I could write println names 0, println names 1, and so on and so forth. Do them all manually, one by one. It's not so bad when we've only got 5 names in the list, but imagine we had 1,000 or 5,000. We're going to end up writing a lot of code. Instead, let's write a for loop to do the job for us. So we're going to start off with I is 0. We know there are 5 names in the list, so let's loop until I is 5, and let's just increase every time. So we're going to println name or names, and this time instead of me saying print the 0 or print 0, print 1, print 2, we're going to put in the value of I. And so we know that I is going to go from 0 up until, but not including 5, so it's going to go 0, 1, 2, 3, 4, and that will print out 0, 1, 2, 3, 4. And so what this for loop is going to do is it's going to increment I from 1 to 4, or sorry, from 0 to 4 inclusive, and it's going to print out the value of names at that place, so 0, 1, 2, 3, 4. So when I hit play, it's going to print out Adam, Bob, Kathy, Derek, Elaine. Now the good thing about this is it's actually, if you then said to me, oh, can you go through, like imagine I was doing my printlns. If you were to then say to me, oh, can you only print out the names of people who have 5 or more letters in their name? That would be quite difficult if I had gone through and was doing it this way, because I would have to say, okay, we saw on Tuesday that a string has a value length, which will tell us how long the string is. So you want to know if they have more than 4 letters in their name. If so, we'll print out the value of length. I now have to add that to every single print, that if statement to every single print statement I have for every user. But with our if statement, we can actually just do it once. If the value of names, which is currently referenced by I's length is 4, just print out those names. And now if I run that, we will get Kathy, Derek, and Elaine. Because the length of Adam's name is 4, it's not greater than 4. The length of Bob's name is 3, which is not greater than 4. Kathy is 5, which is greater than 4. Derek is 5, which is greater than 4. And Elaine is 6, which is greater than 4. So hopefully you can sort of see that by using these for loops that we've just learnt about as, these for loops we've just learnt about, or while, this could all be written as a while loop as well, of course, and these control statements, if, else. We're actually starting to write programs that actually do stuff now. We're not just like add one to this, subtract one from that. Now we're actually like, with this piece of data, let's run over it and do everything. I could do something like, let's print out, what was it, to uppercase, I think there was a function called, which will print out all the names in uppercase. Or maybe I only want to print out if names I dot length is greater than, 4. I only want to print out the names of people whose names are longer than 4 in uppercase. Otherwise, else, print them out in lowercase. So now Adam and Bob's names are in lowercase, and the people whose names are longer than length 4 are in uppercase. So, you know, we're adding one line of code for each one of these new things we want to do, whereas if we were doing this manually, you know, it would be quite a lot of work, because we'd have to do it for each user's name. We'd have to check, is it uppercase, is it lowercase, blah, 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 blah. Whereas using a for loop and some if loops, or sorry, if statements, allows us to run over a huge range of data. And there's nothing stopping this. Like, we're only doing 5 because that's as many names as I could come up with off the top of my head, because I'm still learning all of your names, so I can't use them. But you know, this could be 1 million names, 1 billion names. Well, we can only go up to 2 billion names if we're still using an int loop. Then we'd have to use a long loop, but that's all right. But we could do this over huge data sets, and it would work exactly the same, and there'd be no additional work. Likewise, if I was to end up adding another name, all I need to actually do is just change that one value, and now Fred gets included in the loop as well. And in fact, I'm pretty sure if we go to processing, let me just look up the exact reference. Maybe not. Okay. So there is, unfortunately, I thought there might be in processing a way to get the length of an array. Unfortunately, using the primitive one, there's not. I'm guessing there probably is there is a separate type of array. Oh no, maybe there is. Let's have a look. Oh, yes, there is. Okay. So there's a special, arrays are treated slightly differently in processing. There is a special thing, if something is an array, you can call dot length, and that will tell you how many items there are. So 1, 2, 3, 4, 5, 6. And in this case, we can see I've printed out names.length and it's given me 6, which makes this even easier and more powerful, because I can just change this. Instead of I going to 6, it's going to go until the end of names. Again, if I run this, it'll work fine, but I can actually arbitrarily change the length of names, and this will work with as few or as many names as I give it. So we've now written a piece of code which will take an array of however long we want to give it, and it will go through, and if a person's name is less than 5 characters or 4 or less characters, it'll print it in lowercase. If it's 5 or more, it will print it in uppercase. So we've actually created, I mean, not a useful program, but a program which actually does something now, simply by stringing together a for loop and an if conditional tester. Everyone happy with that? Sort of, hopefully have followed me on the path that we've got there. Okay, cool. So, yeah, I mean, we've gone from very basic, like we're talking about variables and stuff like that, to, in 2 slides, you know, doing nothing, to actually writing programs which you can actually start processing data with. And, you know, this could be, if, let's do another quick example. Oops, I need to make sure there's a number in each of these. Okay, so here's a slightly different example. Now instead of having an array of names, we've got an array of numbers. 1, 2, 3, 4, 6, 4, 1, 4, 6, 7. We have another variable I've introduced called sum, which we set the value to 0 initially. This for loop is exactly the same as the for loop we had before, except now it's numbers.length instead of names.length. But instead of printing something out inside the for loop now, we take the value of sum and we add to it the value of numbers that we're currently looking at. And then when we're finished, we print out the value of sum. So in these few lines of code, we've created a program which will calculate the sum of all the numbers in an array. We could also do some other things now that we have the sum. Let's cast that to a float. We know that if we take the sum of an array or sum of a number of numbers and divide by the number of them, we will get the average. So we now know, that's convenient, there's 10 numbers in there obviously. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, there it is. So we know that we now have, from the same thing, we can have an array of however many numbers we want, and we can calculate the sum of those using one for loop, and we can calculate the average of those numbers by taking that sum and then dividing it by the size of the array. So, you know, perhaps a slightly more useful program than printing out people's names capitalized or not, because now we've effectively put together the first useful tool in Excel, which is the sum tool, which allows us to sum a bunch of numbers. So we can now write that sum thing because we know what it looks like behind the scenes. There'll be a for loop, and it will go over that and add all those numbers together. Okay, let's see how far we get into this one, and then we will break for the day, and that will cover our introduction to programming anyway. So you won't, good thing is you won't have any homework over the weekend because we haven't got to processing yet, but all of this is, as I was saying before, all of this is exactly the same in processing as it is in C#, so as it is in Java, as it is in C, as it is in C++, as it is in a huge range of languages, JavaScript, you know, the fact that you can hopefully write for loops and if statements now, you can do that code in a huge range of languages because it's the same across all of them. So the last thing I want to touch on was functions. So to date, everything we have written has just been, we open up a blank document and we put in some text and we run it. But if I have quite a big program which is maybe doing lots of little jobs, that's going to quickly become quite tedious. Or likewise, if I wanted to do something which did a few operations on some data but did it multiple times, I'd have to copy and paste that thing all the way through the program because it goes from top to bottom and runs a piece of code and then it moves on to the next piece. So in order to avoid doing that, we have what's known as a function or a method. I consider them interchangeable. Some people will say a function has to have a return type and a method doesn't. But as far as I'm concerned, they're the same, and that's what I'm teaching you guys. So hopefully you can make that argument at a later date as well. But what a function does is it allows us to basically encapsulate some code which does perform some function, hence the name, and use it multiple times. So say I had my, let's just do this again. Sorry, everything's falling off the side of my screen. Where are we? Why is that not scrolling back? There we go. Yep, no, print on sum. Okay, so this was the same piece of code I wrote before, which calculates the sum of all values in an array called numbers. I don't actually have the array at the moment, so let's just quickly work that up. 2, 3, 4. So as you can see, this is the function, or the code which calculates the sum of all numbers in an array. But what if I had multiple arrays I wanted to do this on? I'd have to copy this, and I'd have to give them some different names because it's going to complain that numbers already exists. So I'll call that numbers 2, I'll call that sum 2, I'll call that number sum 2, and let's change this array. And we'll print this out now, and we'll get 2 values. The first one is the sum of these numbers, the second one is the sum of these numbers. What if I want to do this 50 times, 100 times, 1,000 times, 1,000,000 times? Obviously, this is going to be quite tedious to have to keep copying and pasting all this code and tweaking it where necessary. So what a function allows me to do is it allows me to basically say, this is some behavior that I want to use multiple times, give it a nice easy name for me to call, and then I can just call that function. So we've already seen some functions. We've seen the println function. We've seen the print function. I can't think of any of I suppose when we did with the strings, so we had a string, and we called it string.length. That's a function. These are all functions, so we're going to write our own now. So I'm going to call my function find sum of array. And that's it, done. Now, I don't know if this will work. No, maybe it will. Sorry, bear with me. I'll write this out and then we'll come back and talk about what's happening. 1, 2, 3, oops, that's right. Just have to check. Yep. Okay. So everything we've been writing to date, we've just written in the editor, and we haven't really worried about any sort of structure. We just copy and paste things willy-nilly, and that's fine. I mentioned with Java, one of the reasons I stopped teaching it was because of this public static void main int args thing, which is the function. And in Java, that is the name of the function that you have to write so that Java knows where to start your code from. Processing does have the same thing. However, if you're not using any functions at all, like we haven't been to date, or we haven't been writing our own functions rather, it will let you get away without worrying about functions. As soon as we put our first function in, we have to start using functions for everything. So there is a function in Java. It is public static void main int args or something to that extent. The same function in processing is void setup. So that is a special function. Once I've written one function, as I have up here, I now have to put this void setup function in, and all my code has to go in there. It's a little bit unfortunate that, that's how it has to be, but that's how it has to be. Otherwise, you'll get this error down here. It looks like you're mixing active and static modes. I don't actually know which one is active and which one is static, but that's how processing defines them, and you can't use both at the same time. So now that we're using, let's say this is active mode, we have to do all our code in active mode, and we've made it active mode by having a function defined. Okay, so let's run this and make sure it does what we expect. 1, 2, 3, 4. 4 plus 3 is 7, plus 2 plus 1 is 10. Okay, so that's working. Let me check with another couple of examples. Okay, so that's 10, that's 16, and that's 4, 8, yep. Okay, so this is all working now. So now you can see I'm able to find the sum of an array simply by writing sum of array and then passing in, if you remember from our println, we had the function name and then we had what I said were the arguments that we passed to the function, so whatever we want to print. In this case, it's the same thing. The name of our function is called find sum of array, and at any point in time, I'm passing in the array that I want it to find, the name of the array that I want it to find the sum of. So in this case, we've created an array of numbers called numbers. We've given it some values and we pass that in, and it prints out the sum of that 10. Here we've created an array called numbers2, given it some values, we pass numbers2 in, and the second thing it prints out is that one. And then we have numbers3, we give it some values, and we call find sum of array numbers3, and it prints out the sum of that. So we've effectively taken that piece of code that we had before, we've turned it into a function, and now to call that function, all I need to do is write its name and tell it what we want to perform on, or what array we want to print it on. Does everyone, that make sense, what we've done, before we go into how we did it? Hopefully. Okay. So, void setup is a function that we've written. Setup is its name, it's a special one, that's why it's bolded in blue. And this is the function that processing will call to start our program. Before we had any functions, so we had something like println hello, we ran that and that worked just fine. Effectively what processing is doing behind the scenes where we can't see it is it's putting void setup like that around my println, and you'll notice when I run this it has the exact same result. So processing is actually smart enough, if we're not using any functions, it will just put this void setup in for us. So setup is the name of the function. As we see in our println thing, we have these circular brackets that allows us to pass in arguments if we want. We have these squiggly lines like we saw in our if statements and our for statements, and that tells us what the function does. So everything between this squiggly bracket and that squiggly bracket is the setup function. So I call setup and it will execute everything in there. Void we'll come back to a little bit later, but that's what's known as a return type. Okay, so let's see, we've got our void setup here. The setup's the name, we know it's a special one, processing will call it, and it does all this stuff, creates some arrays of numbers and then prints, and then calls this function find sum of array. So up here is the find sum of array function that we've written. So let's have a little look at that compared to our setup function. So the first thing to notice is setup is called setup, and find sum array is called find sum of array. And that is also what we write when we want to call the function. So the first thing we have is the name. The name is basically the name of the function, it's how we call it. There we can, again, in the same way we can call variables whatever we want, we can call functions whatever we want within limits. Processing has some special functions like setup that we can't reuse because setup is what it calls when it starts running, but find sum of array is fine. And I could call this whatever I wanted to within limits. So then we have our squiggly brackets from here to here. And inside that is this array, this little chunk of code we wrote before, which loops through all the values in an array called numbers, adds them to the value of sum, and then prints out the value of sum. So we wrote this code before. Hopefully you're happy enough with that. So then there's a couple of other pieces. We have, for our function, in setup we have circular brackets with nothing inside them. Here we have circular brackets, and inside it we have this int square brackets, numbers. And that's what's known as an argument. So this is some data that we're going to give to our function to tell it what it needs to do. So in our println function, inside our circular brackets, we had sum, and that is the data that we're passing to println to print out. Here, we have this int array called numbers, and that is what we pass into it. So here we say find sum of array with numbers, and perhaps I should have used a different name. Let's try and make this slightly less confusing. So here we have my numbers, and it's an array, and we're going to pass that into find sum of array. So find sum of array my numbers. We're saying that we want you to find the sum of the array which is stored in my numbers. So this chunk of data here gets passed into this array, and it gets stored in a variable called numbers. So this numbers has a different name as this, but that's just because we want to be able to use this for lots of different things. We could call this whatever I want. I could just call it array or something, because the function doesn't care what it's called. It just needs a name so it knows what to refer to it as later on. So this my numbers here gets copied into an array called array, and then all the processing happens on array, and the sum gets printed out. So in the first case, we create this array called my numbers, we give it some values, and then we pass that in to find sum of array. So this data here gets copied into here, and then we perform this algorithm. When we're done, we come back out, and then we create a new array, and then we take its value, 4444, which is stored as my numbers 2, and we pass this in here. So now this array has the values 4444, and it will loop through, calculate the sum, print that out. Then we come back here, because once we've finished executing, or when we call this, we go through run this code, and once we hit this bottom bracket, we come back to where we start and move back to the next line. So we do that for this one, we do that for this one, and then we come to this one. We have 1, 1, 2, 4 stored in my numbers 3. We call find sum of array. It will pop up here and fill out the value of array with what we passed in, which is 1, 1, 2, 4. Calculate the sum, print that out, and then it will return back to setup, and then setup is finished, it'll return. That's the end of our program. So we will end up getting all these things printed out. Right. We only covered a couple of things, but we've covered, and we'll come back to this on Tuesday again because I think it'll probably need a refresher. But we've covered the naming of array, so we can give it a name, which will be the name we use to refer to it later on. So we've called it find sum of array, and down here we can access it by find sum of array. So that's the name. Calling it is literally just writing its name and then putting the circular brackets after it. If it has any arguments, in this case println takes in something we want to print out, find sum of array takes an integer array that will be printed out. We need to pass that in as well. So that's what the arguments are. We basically specify here what we want when someone calls our array, what we want them to pass in this case an array of integers, and then when we call it, we have to pass in the array of integers for it to process. We didn't get as far as return types, but we will deal with that next week because I think based on the look on everyone's face, everyone's had enough today. And I know that I certainly have, because it's hard to teach this stuff. Like, it's quite abstract and just quite difficult to sort of communicate the ideas. So thank you for sticking with me as long as you can, and everyone's still awake, which I take as a pretty massive win. I will save this and I will put it on Learn, so you guys are welcome to have a little play with it and open it up. Again, I would highly recommend, the lecture slides are on Learn. Please go back, and if you haven't already installed processing, please go back and work through these 3 programming basic slides. Make sure you understand and can do the stuff here, and if there's anything you don't understand, don't feel bad about that, but come on Tuesday and tell me, and we can go over it again. Because it's one thing for me to tell you guys and you think, oh yeah, okay, I understand it when someone else has done it, but you guys need to be able to understand this and be able to do it for yourselves. And there's quite a big difference between seeing someone else program and understanding what they've done and actually being able to do it yourself. And that's, for me, something that when I first encounter a new language, I can often see what someone else has done and be like, okay, I can follow through how that works. And then if you say, okay, write your own stuff in this new language, I'll be like, I don't know where to start. So even as somebody who's been doing this for, well, I mean, I started programming when I was 8 years old, so approaching 30 years now, you know, it is something that first time I see a new language, I can understand what other people have done, but I can't do it myself. And I'm sure for a lot of you guys, you're probably in that same boat now. You can follow through and I do the examples, but you can't, doesn't necessarily mean you can write it yourself. The only way you can get there is by practice. So, you know, until next Tuesday, spend, 15 minutes, 30 minutes a day just playing around with, going through these slides, playing around with the stuff. Try and figure it out. If you can't figure it out, come back and we'll talk through it again. I'm more than happy to, work with you guys either in the class, or you can always come up to me and ask me, I've done this and it doesn't work. Can you please explain what I've done wrong? I don't understand this. I'm here to help you guys, to teach you guys, but you're going to have to meet me halfway and do the work as well, because me talking like this at you guys for 2 hours is not going to make you expert programmers. Cool.